Sample problem 17.11. Which of the following compounds will be more soluble in acidic solution than in water? CuS, copper sulfide, AgCl, silver chloride, PbSO4, lead sulfate. So here's what you want to do. So I'm going to write down the chemical formulas of these compounds. And then write out the expression for them dissolving. So when copper sulfide dissolves, you get the copper 2 ion and you get the sulfide ion. So that means KSP is equal to the concentration of copper 2 times the concentration of the sulfide ion. Let's try B. B, we're talking about AgCl. Now that's one that's used quite a bit in examples. We've seen it before, previous examples. You get the silver ion concentration and the chloride ion solution concentration. So KSP is concentration of silver times concentration of chloride. And then C is PbSO4. So when that dissolves, you get the lead 2 ion and the sulfate ion. So KSP for this one is the concentration of lead there we go. Okay, so there's our equilibrium expressions for all three. Now, the issue here is we're going to make it more acidic. So the question is, will the negative ion, the anion, the anions, the negatively charged ions, are conjugate bases of some acid. So the question is, will they react when we make the solution acidic? So I'm going to show it this way. The issue is, will the hydronium ion react with a sulfide ion to form HS minus, right? So this is acting as a Bronsted acid. This is acting as a Bronsted base. This is your conjugate acid, and then water would be the conjugate base. So here's the issue. If this reaction does occur, that means that the sulfide concentration will decrease when you make the solution acidic. In this problem, we're told that we're making the solution acidic by adding probably a strong acid, for example, hydrochloric acid. So when you make a solution acidic, what you're doing is you're adding the hydronium ion. If you add the hydronium to the sulfide ion, will this reaction occur? That's the question. If it does, that means the concentration of sulfide will go down, and according to Le Chatelier's principle, the reaction will return to equilibrium by moving to the right, producing more of the products, thereby increasing the solubility. Okay? More of the copper sulfide will dissolve if you take sulfide out of the solution, S2 minus. So really the issue then is HS a weak acid? Is it a weak acid? If it is a weak acid, that means the sulfide will react with hydronium to form HS minus. So you just need to find out if HS minus, the conjugate acid of the sulfide, is a weak acid. And it is. If you go back to chapter 16 and you look in the table under polyprotic acids, okay, there's a table for polyprotic acids in chapter 16, which gives you a list of all the conjugate bases of polyprotic acids. Okay? And so that table is laid in the chapter. It's in table 16.8. And what it tells you is that HS minus has a Ka of 1 × times 10 to the minus 19. It's very small. So that means that HS minus is a weak acid. If it's a weak acid, sulfide will react with hydronium to form the weak acid, thereby reducing the concentration of sulfide, thereby increasing the concentration of copper sulfide. Very interesting reasoning, right? It's not as simple what happens. You need to think through several different steps of what could happen. Let's try the second one. AgCl. If we make it acidic, the question is, will chloride react with hydronium? And the answer is no. This is the conjugate base, not of a weak acid, of HCl, which is a strong acid. Strong acids are not formed by their conjugate bases reacting with hydronium. So we're not going to get the reaction to form HCl and water. It doesn't happen. In other words, acidifying the solution has no effect. So the answer to part A is solubility increases. For part B, solubility stays the same. It does not change, not up or down. Now let's look at the last one, lead sulfate. So again, you look at the conjugate base, sulfate, and you ask, will it react with hydronium to form HSO4 minus and H2O? That's the question. So you look for it. You look for this guy right here. Can you find it anywhere? So you have to look through all the acid dissociation constant, the ionization constants for acids. Now, since you see it's HSO4 minus, it looks like it's from a polyprotic acid. And if you look at it, the value of Ka for HSO4 minus is 1.3 times 10 to the minus 2. It's less than 1, so that means it's a weak acid. If it is a weak acid, that means yes, this reaction will occur. In other words, acidifying the solution by adding this will react with this, reducing the sulfate concentration. This will go down, so the reaction will shift to the right according to Le Chatelier's principle. To reform of it, more dissolves. So some salts become more soluble if you acidify the solution. So for this one, yes, it increases.